Hello, hello, Algebra 2 students. This is Dr. Heron talking to you about Unit 2-1, talking about the basics of functions and function notation. Basically, how do functions work? What are kind of the important parts of them? And then what do they represent? And how do they translate to a coordinate plane? So, if I look at relations, okay, relations are just basically about what they sound like, okay? All you're doing is comparing, all right? Oftentimes, two sets of numbers, okay? These numbers can represent a whole bunch of different things. You can kind of put any context you want on it, but basically, a relation is comparing like x values to y values. So that can be in an ordered pair, a table, a graph, or a mapping diagram. Probably the most familiar you guys are is with these two, and then the application is these two. But the mapping diagram, this is something that's very, very helpful, just to kind of give you a visualization of what can happen. All right. So a function is a specific type of relation where you've got one input and one output, okay? So it is one input gets you one output, all right? So these are all of the graphs that you've probably been exposed to at least a little bit in some way, shape, or form, especially ones like this and this. You've seen quadratic before, although you haven't spent a whole lot of time with it. Cubic, absolute value, square root you've seen. You probably haven't seen these three too much, but maybe you have. But those show up a little bit later. But those are kind of the ones that you're probably most familiar with or at least seen before in the past. So this is your function notation, kind of a lay of the land, if you will. So please note that I know every other time we've said parentheses mean multiplication. That is not the case here. This says f of x, okay? Now, this is your function name, okay? This is like, in this case, you're saying function f. Sometimes another popular one would be like function g. Those are a couple different things that you can name your function. So basically, this is identifying a specific function with a specific name. Okay, so the x is going to be the variable that you operate on. Okay, it's saying whatever value goes in there, that is, whatever number goes in there, that is what I am doing. Okay, so f of x, that whole thing would be considered your output. Okay, so it's what happens once x has been put in there. Okay, so by the way, this would be considered your input. And this is your output. This would be kind of your final answer after you do all your operations, after you do everything to your number. Okay, so this ends up being your function rule. And it's basically, what are you doing to this variable? All right, what are you doing to this variable? In this case, we'd be multiplying by 3 and adding 4. All right, so f of x, this box right here, for a lot of you, that's probably going to be the most comparable to saying the similar thing as like y equals 3x plus 4. Okay, this you're talking specifically about the graph. F of x, you're focused more on the actual function. So if I figure out the f of 2 and the f of negative 1, so each time it is 3x plus 4. If I put in a positive 2, if I take f of 2, so that's 3 times 2 plus 4. So my output is going to be 10. If I take f of negative 1, 3x plus 4, so that'd be 3 times negative 1 plus 4, so that's going to be 1 for my output. So, written a different way, the f of 2 is 10, and the f of negative 1 is 1. So, vertical line test. If I have a graph, if I can draw a vertical line and hit no more than 1 point or 0, then the graph is a function. Okay? So this is like 1 or 0. If I hit 2, it's not a function. Okay? If I'm looking at a table or the mapping, no repeating x values. And I'll show you kind of what I mean by that. Okay? So if I look for letter A, every input goes to one specific output. Okay, I know both of these go to 0. That's fine. That's fine. They each have a unique, they each have one output, okay? That is different than down here in D. Down here in D, you notice how 2 goes to both 2 and 3. That is not okay, so that makes that one not a function. That makes this one a function, okay? So this one is a function. This one, no. If I look at letter B, I have negative 1 to 2 and negative 1 to 4. So that's going to be no. Okay, I've got negative 1 going to 2 different numbers. That's a no. Letter C, vertical line. Yes, I could draw a vertical line right here and hit 0. That doesn't make it not a function. But over here, if I draw a line, I hit 2 different points, or if I do it over here, so that's no, not a function. Okay, notice the difference. Different inputs to the same is fine. One input to 2 outputs is not fine. Okay, so if I've got this simple function up above, what am I doing? Literally, you're just playing substitution and then doing order of operations. So that'd be like 3. Let me do a color you can actually read. So that's going to be 3 times 2 minus 2 times 2 squared. So 3 times 2 is 6. 2 times 4, negative 2 for an answer. G of 3 times G of negative 1. So I need G of 3, which will be 3 times 3 minus 2 times 3 squared. So 3 times 3 minus 2 times 9. So 9 minus 18 yields negative 9. G of negative 1 is going to be negative 3 times negative 2 times 1. So that's going to be negative 5. So when I multiply this, my final answer will be 45. So G of 3x says I literally put in 3x exactly for x. All right, so that first part will be 9x. This will be 2 times 9x squared. So it'll be 9x minus 18x squared. And that's as far as I can go. Okay, do not combine those. So now here, we're going to play a little musical functions. So G of 10 would be negative 3 times 10 plus 1. So negative 29. F of 3 is going to be 3 squared plus 7. So 9 plus 7. so 16. For h of negative 2, I'm going to take 12 divided by negative 2, so that's going to give me negative 6. That's this function right here. So the j of 7, we're going to literally put 7 in there where x is. So 2 times 7 plus 9. I don't know why I put 2. I'm getting ahead of myself. Don't do that. 23 should be my answer. Now, h of a means I'm going to put a in for 12, and that is as far as I go. That's an a, not a 9, by the way. And lastly, g of b plus c. This one gets a little bit interesting because I go to function g. So I'm going to have negative 3 b plus c plus 1. So that'll be negative 3b plus a negative 3c plus 1. There's my answer. So now, working backwards, you're given the function value, and you've got to work backwards. So g of x is 16. So negative 3x plus 1 is 16. So now solve. So negative 3x equals 15. X equals negative 5. So figure out x if h of x is negative 2. So that one is just going to be 12 over x equals negative 2. So if I multiply both sides by x, 12 equals negative 2x. Divide by negative 2, x will equal negative 6. Now they're saying j of h is 9. J of x is 9. So I'm going to go back to j of x. So 2x plus 9 equals 9. So 2x equals 0. So x equals 0. Okay, so you've got this function. We've got a totally arbitrary and made up problem. S of x is 9x minus 4. People have swine and they have t, time in days. S is number of people in thousands. So what is the S of 4? That's going to be 9 times 4 minus 4. So that will give me 32. So what that means is that after 4 days, okay, I'm going to have 32,000 people with swine flu. All right? Now, figure out when does the function equal 23? So when does 9t minus 4 equal 23? Well, 9t equals 27, so t equals 3, so 3 days. So what does that mean? That means on day 3 of this flu epidemic, 27,000 people have swine flu. Okay, so now graph the function. So if I go 9x minus 4, so it's going to be there. So I go up 9 over 1. There is my graph. Okay, please come let me know what questions you have, and then we will talk soon.